Welcome to Advanced Linear Electronics Online, Chapter 7, Section 4, Part 2. We'll be using this information to complete a report. I'll provide guidance on Blackboard soon. We're still discussing the 555 IC, and this slide here shows the functional block diagram of the inner workings of the integrated circuit. One thing I didn't make clear in the last discussion is that pin 4 reset is an input, and it's active low, so if you tie it to VCC you disable this function. This slide provides the definition of each pin that could be used as a reference. So in part 1 of this overview we covered the monostable or one-shot mode of operation. In this session we're going to cover the final two, bistable and astable modes. So bistable, it has two states. It's either high or low, and it's a very simple configuration, doesn't require any timing components added to the circuit. So basically this configuration will set the output high, pin 3 high, when the trigger is grounded, as it's shown. Or if we change the switch to the reset, we ground the reset, then the output will go low. So I did a multi-sin setup of this circuit. Notice that the current state of the trigger input's grounded, causing the output to set high. And when I change the position of the switch to ground the reset pin, it goes low. That's all there is to it. Pretty simple. And so the switch could be a circuit giving a low or high as well. Now we're going to switch to the last mode, and that's the astable configuration. Astable means having multiple states. This is essentially a free-running oscillator, and it provides a square wave signal at a specific duty cycle. It simply requires an RC network external to the IC. So here are the external RC components to the IC. And this is an astable configuration, and what the result is a pulse train of a square wave. And the formulas here are used to develop this circuitry. So we'll be able to develop the time high, which is here, the time low, that's T2. And then if we add those together, that's the period, and then we can also determine the duty cycle. And all these formulas include R1, R2, and C1, even though it's just labeled as C here. So in this configuration, we connect pins 2 and 6 together, and also notice that pin 8 is our power. Pin 4 we're disabling, it's the reset that's active low that I talked about earlier. And during each cycle, C1 charges up through R1 and R2, and it'll discharge through R2. The discharging occurs at pin 7, the discharge pin. The output of the square wave is still at pin 3. So let's look at an example. The first design computation is for time high. So if we're given these components, R1's 1K, R2's 2K, C or C1 in our schematic is 10 microfarad. We'll determine first of all using this formula the time high. And we'll also determine time low. So if we add those two together, we get the period, 35 milliseconds. So the inverse of the period is frequency. And these two formulas can be used to determine the duty cycle of the waveform. Both are valid depending on what kind of data you have. If you're measuring something like the data, you could use this. Or if you have components you're designing, you can use that. So the setup that we've shown with the astable mode can never go below 50% with that configuration. However, the next slide I want to introduce another setup or configuration to allow us to go below 50% duty cycle. So here it is. We have a couple of diodes that are inserted. What we have to be careful with, if we use this setup, we have to use different formulas to compensate for that. The big thing here is that the charging of C1 occurs through R1 and D1. We have to remember that the diodes allow current to flow through in one direction, and the arrowhead indicates the direction of the current flow. So D1 allows all the charging current to come through R1 and bypass R2. Really, D2 is preventing any charging to go through R2. However, when we discharge, it prevents the path going this way, and we go through D2 to R2 to the discharge pin. So it's pretty slick. So here's an Astable setup that alternates between sourcing and sinking. So here we sink the current, and here we source the current to turn on the LEDs. This produces a 2 Hz signal at pin 3. So for homework, I'd like this to be completed by April 7th. Problem 729 on page 357. Build a 555 IC bistable mode, either on a breadboard or in multisim. And you can look at slide 6 for an idea how to set that up. And here's the components. R1 and R2 should be 10K. Measure the voltage of pin at the output pin 3. And we want to measure the voltage at pin 4 and 2 for each position of the switch. Next, I want you to build an Astable circuit using the diode equations in slide 17. Develop a square wave oscillator with a 40% duty cycle. So it's a design problem. Then number 4, build the circuit listed on slide 18 with one exception. Change that capacitor of C1 from 10 microfarad to 5. So keep your homework. This information will be used to help you complete your group project. I'll announce the details of that later. Have a good day. Bye-bye.